So this fits well with the talk that we just heard. We're interested in setting up a 1 or 2 order of magnitude improvement of lunar dynamics, and this is really global lunar dynamics, selenodynamics, if you would, and geodynamics. And I wanted to talk a little bit about the science here, because I get a pushback from a lot of people as to why you might want to do this, or why they feel you don't need to do it. And so basically, if you remember anything about this talk, remember this line here: the moon is not dead, and we want to keep track of it. Okay. The next slide, please. I can't do that. So there's also a very practical application here. Lunar PNT is, it's going to, we need a PNT system for the cislunar realm. I mean, that's pretty clear. The LunarNet is working on that. It's not entirely fully baked, in my opinion, for PNT, but it's getting there. But it's going to require, really, to do this, I think, accurate lunar dynamics, and better than we have now. Now, the moon is more dynamically stable than the Earth. There's no question about that. The moon doesn't have oceans, doesn't have an atmosphere, doesn't have the currents these things have. The Earth varies dramatically on a short period because we have an ocean and atmosphere. The moon does not. So you might think, well, okay, so the moon's just static. Well, it's not. Okay. And one of the things, so I'm going to go through the things we expect to see and to improve. 50 years of lunar laser ranging data has seen that because of exchanges of tidal angular momentum, the moon is moving away at about 38 millimeters per year. That's actually based on a change in the lunar longitude more than the actual determination of the change in semi-major axis. And that's about 4 meters per year squared. That's a pretty big change. Okay, we don't know anything about the details of this change on a short time scale. Is it constant? Does it vary? If it does vary, that's going to affect, the PNT. Significant. There are free rotation resonances in the lunar libration. Their amplitudes are order meters. We don't know what causes them. They're moonquakes. We know they're moonquakes. We know things move by meters, and we don't know much about them either. And there's Apophis and other asteroids are going to be perturbing the moon, and we've actually done a paper on this. It's hopefully going to come out soon. And so how are we going to improve this? We're going to improve this by using differential VLBI, very long based on interferometry, and differential LLR. And that can easily start with a fiducial point, a geodetic fiducial point at the Artemis station. And oh, by the way, this also fits in well with what came out today from the Office of Science and Technology on coordinated lunar time, because that's, you need lunar rotation for that. Thank you very much. Take care.